Hello and welcome to the 27th episode of the Python tutorial series. Last week we discovered how to plot 3D graphs using Matplotlib. In particular, we saw how to plot surfaces, contour plots and wireframes. Make sure to check that video out if you've missed it. Also, if you haven't yet done so, make sure to subscribe to the channel so you don't miss any of my upcoming tutorials. If you have any questions, remember to leave a comment below and get the chance of being featured in my next Q&A video. Now though, let's move on with today's topics. First, we will learn how to plot a 3D line chart. As you can see, I have already created 3 arrays for our X, Y and Z axes. Now all we have to do is write fig equals plt dot figure and then ax equals plt dot axes with projection equals 3D. This, if you remember, is the same as for the 3D plots we saw last time. Now, to plot the 3D line chart, we can write ax dot plot x, y, and z. As usual, we can write plt dot tight layout followed by plt dot show. Now, as usual, we can press the F5 key, and there you have it, a spiral-shaped line chart. If we use the same dataset, we can also create a 3D scatter plot. All we have to do is substitute line 12 as follows. We can write ax dot scatter of x, y, and z. Then we specify c equals z and cmap equals viridis. In this case, we specified that c is equal to z. What this does is it assigns the values of the z array to represent the color intensity of each point. Therefore, when we apply the viridis color map, that's what cmap stands for, by the way, we get this nice pretty graph. Talking about color maps, we've seen that the only variable you have to change is the one called cmap, with the exception of scatter plots where you also have to specify the color array called C. But what other color options are available? Well, theoretically you could generate any color combination by creating your own custom color maps. Helpfully, however, Matplotlib provides us already with a vast number of default color maps to choose from. Here are a few examples taken from the surface plot we generated in last week's video. Now that we've seen these, let's look at one more trick we can use with contour plots. First, let's look at the code we wrote in the previous episode to create our contour plot. As you can see on line 15, in addition to the x, y, and z arrays, we have a number 40. Do any of you know what this value means? Write your answer in the comments below and see if you can guess correctly. I'm sure some of you have certainly figured out that this represents the number of contour lines generated in our plot. So depending on how tightly or widely spaced we want the contour lines to be, the higher or lower this value will be. Here, as you can see, are 3 examples of the same contour plot, each with 20, 50, and 100 lines respectively. Now that we've seen this final trick when using Matplotlib for contour plots, it's time to end today's episode. I hope you enjoyed this video, and if so, don't forget to like and share it with your friends, and subscribe to the channel to be notified of any new episodes. If you've missed any of my previous tutorials, you can check them out by clicking on the box in the top right hand corner of your screen or on the link in the video description. Also, if you want to put your coding skills to the test, then take on my coding challenges. You can find a link to these in the top right hand corner of your screen and in the video description. As always, I look forward to seeing you in my next video. Have a great week, and until next time, happy coding!